Hey guys, how you all doing? It's Shalajor here again, back with another video from BHM at GCSE Chem, and today we're going to be doing section C4.4, which is called the yield of a chemical reaction. And I didn't make a video yesterday, I was quite busy, so unfortunately I couldn't make a video, so I'm really sorry about that. But I am making a video today, and also yesterday was one of my friend's birthday, so I would like to wish him a happy belated birthday, and I hope you had a great day. And by the way, my friend's name's Kia. He really supported me. He supports me a lot, and he was the one who really got me into making YouTube videos. Making my own YouTube channel. So, he really got me interested in it. He's a really great friend. So I hope you had a great day yesterday, and a happy belated birthday, Kia. I like Kia or Kia, but I call him Kia basically, but Kier. That's how you spell his name. But yeah, I hope you had a great day there. So that's what I wanted to say. And so as I said before, we're doing C4.4, the yield of a chemical reaction, which is only for triple science students. So here, and by the way, this is the book that I'm using, the AQA GCSE Chemistry Revision Guide from Caboodle. And so today we're doing C4.4, the yield of a chemical reaction. I know I say it quite a few times, but just to let you know again, as I said before, we're doing that topic, and this is only for triple science students, only not for combined science students, only for triple science. So students studying triple science. So again, I'll put it on the title. I'll put TSS only to indicate that. And there was 2 days ago, I made a video saying that the GCSE results, they might be deferred. Not deferred. I don't know if deferred is the right word, but basically it's pushed back for a couple of weeks. I think deferred is right. I don't know, whatever. I mean that it's going to be pushed back by a couple of weeks, but it's not. It's tomorrow, and I want to wish everyone very good luck for results day tomorrow, GCSE results day. And one big news is everyone for GCSEs and A levels. In England, everyone in England will be getting their centre assessed grade, or the CAG, which is their teachers' grades. So basically, even A-level students who got downgraded, they're going to get the grades from everyone. Even all the A-level students are going to get their grades, their teachers' grades now, and and those are the grades that GCSE students will receive as well. They're also going to receive their centre assessed grade, which is the grade from their teachers, just to let you know. And results day is tomorrow for GCSE students, so I hope you really don't stress about it. It's not in your hands, but good luck for tomorrow. I just wish everyone the best of luck. And tomorrow I'll be doing a why you should take A-level chemistry. So is A-level chemistry right for you? Why you should take A-level chemistry, stuff like that. I'm not going to be making a content video, like a teaching video. I'm going to be making that kind of video so that it can help students decide whether they want to study A-level chemistry or not, and I'll be sharing my experience of it so far. Obviously COVID hasn't made my experience really good, but I mean the subject is really interesting. It's just that we haven't been able to go into lessons, and it's been quite weird this year, for everyone, but I think let's move on from that. I'll be doing that video tomorrow, and I haven't been able to put the links up to the YouTube of my YouTube videos on my website yet, so I'll be trying to do from C3.2 to C4.4, from C3.2 to C4.4, which includes today's one. The C4.4 is the yield of a chemical reaction. I'll try and put all the links up on my YouTube, on my website. I'm really busy nowadays because of mocks and stuff, so I'll try and do it. If not, I'll try and do it as very soon as possible, basically ASAP. And as I said, this is only for triple science students only, and I think I showed you the book as well. Just in case I didn't, it's this one, the AQA GCSE Chemistry Revision Guide from Caboodle. I think I did though. There we go, I just showed it again. And I think that's it from that kind of point of view. I have that's it from all the introduction. I have a pen and paper again, because this is calculations, and a calculator as well. I'm going to be using my A-level calculator there to do the calculations. But let's do it. So C4.4, the yield of a chemical reaction, and if you're following the student book, it's pages 68 to 69. So the yield of a chemical process is how much you actually make. The percentage yield compares the amount made with the maximum amount that could be made calculated as a percentage. So it's basically just a ratio given as a percentage. It's basically a number that is that's what yield of a chemical reaction is. It's how much you actually make compared to the maximum amount that could be produced, and we express this as a ratio and a percentage. Basically, we express the ratio of this as a percentage. Basically, how much you actually make divided by how much you theoretically make, times that by 100. So that's what percentage yield formula is. That's to calculate percentage yield, you do actual yield over theoretical yield times 100 to get percentage. Obviously, you always times by 100 to get a percentage. Now here's calculating percentage yield. That's for higher triple science students only. I'm pretty sure triple foundation students don't need to know this because it does say higher. And by the way, if you're following the student book, I don't know if I mentioned this, but it's pages 68 to 69 that you'd want to go that you're looking for today, basically. And so the percentage yield is only for higher tier students for triple science. I think there's triple foundation as well. So triple foundation don't need to know this, but I might be wrong. But in this book it says higher, so I presume higher just means it's triple higher. It's definitely not combined higher because this is not for combined science students, it's only for triple science students. But I think this is only for specifically for triple higher students, not triple foundation. Hopefully, I think that's right, but I might be wrong. Check that. Make sure to check that. Just in case. So the percentage yield is calculated using this equation. So it's percentage yield is mass of products produced over maximum mass of product possible times 100. That's basically what I said. I said actual yield over theoretical yield times 100, and that could be expressed, using masses. Mass that you actually produce over the mass that you can theoretically produce. So mass of product produced, maximum mass of possible product. No, maximum. So percentage yield is basically mass of product produced divided by mass of maximum mass of product possible times 100. So hopefully that makes sense. And here's a worked example. So the maximum amount of product can be calculated from the balanced equation for the reaction. So the maximum amount of product possible is calculated from the balanced equation for a reaction. So here, for example, a student collects 2.3 grams of magnesium oxide to form 2 grams of magnesium. So theoretically, we need to write an equation. So whenever you're told an equation like this, you need to be able to formulate the equation itself. So we're told that we're making magnesium oxide from magnesium. So obviously that means we're going to be using oxygen. So basically what I'd be doing is I'd write the equation basically, and then I'd balance it. And don't worry about the state symbols here. It's not that important in this case, unless they ask you obviously in the exam. But I'm not going to go through how I balanced it, but that's how you balance it. This should be the equation, and that is, so hopefully you can see it, 2mg plus O2 gives you 2mgO. I think we've seen this equation before actually in the last section maybe, but there we go. Let's move on. So theoretically you can have this obviously. So it says, for example, a student collected 2.3 grams of magnesium oxide from 2 grams of magnesium, and they might ask what is the percentage yield of obviously the product, which is obviously the magnesium oxide. So if we have 2.3 grams of magnesium, now there are two ways of actually doing this. So I'm going to do it the book way first, and then I can even show you the other way as well. Either way is right, and I prefer the moles way, the one that's not in this book, but you can do it either way. So if you have 2.3 grams of magnesium, that means you have 48 grams of you have 2.3 grams of magnesium oxide. Sorry, wait. The student collects 2.3 grams of magnesium oxide from 2 grams of magnesium. So we have 2 grams of magnesium. Now we know that we can work out the relative form mass of we can work out the mass of magnesium here. It's 2 mg, so that's 2 times 40 is 80. So that means what we could have is 48 grams. No, what am I saying? Magnesium has a relative atomic mass of 24. So 2 times 24 is 48. So that means 48 grams of magnesium can produce how many grams of magnesium oxide? Now the relative formula mass for magnesium oxide is 24 plus 16 is 40. But because you have 2 of them, it means you have 80 grams. So hopefully that makes sense. We've been through relative formula mass and relative atomic mass calculations before, so this shouldn't be that hard. Not going to go through it, but basically we know that 48 grams of magnesium, because it's 2 times 24, that 24 comes from relative atomic mass from the periodic table, obviously, and relative formula mass of magnesium oxide is 40, but because you have 2 of it, it means you have 80. So if 48 grams of magnesium can produce 80 grams of magnesium oxide, what that means is we have 2 grams of magnesium. So then if we divide by 24, both sides by 24, then that means, so we have 48 grams. So basically 2 grams would basically then produce 80 over 24. Wait, let me just make sure I'm doing it right. 80 over 24. Yeah. So this will basically be producing, what does it say here? So 2 grams would produce 2 times the ratio. Yeah. So obviously what we have is 48 grams of magnesium produces 80 grams of magnesium oxide. If we divide both sides by 48, we get 1 gram of magnesium produces 80 over 48 grams of magnesium oxide. But basically we need to work out 2 grams, so we're just going to double it. Or another simple way is, if we have 48 grams and now we're looking at 2 grams, we're dividing by 24. So we're going to divide the 80 grams by 24 as well on both sides. So we divide that, we're going to get 3.33 or 10 over 3. Either way, you form 3.33 grams of magnesium oxide. Now that's how much you can produce. So it says 2.3 grams is collected, but 3.3 grams is possible, or 3.33 grams is possible. So then you do 2.3 grams over 3.33 grams, basically recurring. And I think I'd write 3.33 as 10 over 3, and then times that by 100, and it's about 69%. So you get 69%. So hopefully that makes sense. Now that method is good, but I think there's a much better method in terms of moles. Hopefully that makes sense. What I'm doing is just common ratios, really. You need to know that. And here I could just write, here I did 80 over 24. The reason why I did 80 over 24, because I knew I had 2 grams of magnesium, so I had to divide by 24. So here I'd divide by 24 as well, and I got 3.33 or 10 over 3. I got 10 over 3 specifically, but I just wrote that as 3.33. But either way, I got 69%, and I did 2.3 grams, which was the mass of magnesium oxide that I actually produced, over 3.333 grams, which was obviously the theoretical, which the maximum mass of product, times it by 100, 69%. Now another way, I think a better way, you get the answer either way. But because we have 2 grams of magnesium, now what I could do is I have this balanced equation, right? So let me write this balanced equation again. 2 mg plus O2 gives you 2 MgO. So I have 2 grams of magnesium. And now I can work out the number of moles of magnesium I have. So I have 2 grams, so I know number of moles equals mass over mR. So I have 2 grams over the mR of magnesium, which is 24. So if I do 2 over 24, remember that's from the periodic table, the AR of magnesium, because that's obviously a single one. Remember, we use AR for single ones, or molecules, and we use MR for relative formula masses and stuff. So that gives me 1/12. 1/12 mole. So I have 1 over 12 mole. I think it's better to write it as 1 over 12 because I did 2 over 24, so that I can work out the number of moles of magnesium, because I had 2 grams over 24 was the relative formula mass. So 1 over 12. Now, because it's a 1-to-1 ratio, you can see 2 mg produces 2 MgO from the balanced equation. It means the number of moles of MgO equals 1 over 12. So the mass, then therefore, the mass that we can produce of magnesium oxide would be 1 over 12 times the relative formula mass of magnesium oxide, which is 80, because we did, not 80, sorry, not 80, it's 40, isn't it? Wait. Yeah, sorry, 40, because obviously before we did 2 MgO, so it was 80, but if it's MgO, it's just 40. So that means we again produced 10 over 3 or 3.33 grams. So that's how much the maximum that we can produce. And then we just do 2.3 divided by 3.33, or 3.33 can be written as 10 over 3. But we do that calculation, times it by 100, and so we should get 69%. Yeah, we do get 69% that way as well. So you can use moles, which I find easier and I find better, but you could use either way basically. You could use both methods and you get the right answer. And so now we're going to the example here. We've done that question. Now here's another question. So the first question, that was a worked example. Now a student made, here's a question. So a student made 4.4 grams of calcium oxide from 4 grams of calcium. Calculate the percentage yield. Now the AR of calcium is given to us 40, and the AR of carbon is 12, and the oxygen is 16. And so the AR of oxygen is 16. That is from the periodic table, from the big numbers in the periodic table, and from the top numbers of each element. So I'm only going to go through one of the methods, so I'm not going to go through both, because obviously it's taken a long time already. You should understand both, though, just for the exam. You should be competent in both, understand both. So we have 4.4. First I'm going to write the equation. So I have calcium plus oxygen. I'm not going to go through the balancing, because that we've been through that before, and you should know how to balance it now. So again, it's very, very similar, like 2Mg plus O2 gives you 2 MgO. This is just 2Ca plus O2 gives you 2CaO. I just wrote the 2 on the top of it, but you get what I mean. So what we have is we have 4 grams of calcium. Now I'm going to do it in the moles way. I like the moles way. So what we have is 4 grams of calcium, right? We divide that by the molar mass of, the mass of calcium, basically the relative atomic mass of calcium, which is 40. So that gives me 0.1 mole of calcium. Hopefully you can make sense. The number of moles equals mass over mR, or mass over AR. So 4 grams, we were given 4 grams of calcium we were given 4 grams of calcium, so we divided that by 40, because the AR of calcium is 40. So that gives us 0.1 mole, or 1 over 10, which is 0.1 mole. And then we know it's a 1-to-1 ratio, because that's 2 calciums gives 2 moles of calcium produces 2 moles. 2 moles of calcium react with 1 mole of oxygen to produce 1 mole of oxygen molecules. 2 grams of calcium atoms react with 1 mole of calcium, 1 mole of oxygen molecules to produce 2 moles of calcium oxide, basically. And so it's a 2-to-2 ratio between calcium and calcium oxide. That means it simplifies to 1-to-1. Therefore, the number of moles of, which we write as N, of calcium oxide is also 0.1. That's the number of moles of calcium oxide. Now, what's the relative formal mass of calcium oxide? Well, that of calcium is 40, obviously 40 plus 16 for the oxygen, so that's going to be 56. So that's actually going to give me 0.1 times 56, which is 5.6 grams. So that's how much calcium oxide I have now. I have 5.6 grams of calcium. That's how much I can theoretically produce. Now it says student made 4.4 grams of calcium oxide. So again, I just apply the formula: 4.4 grams over 5.6 grams, and times it by 100. And I should get, let me see what I get. 4.4 divided by 5.6 times that by 100, and I get 78.6% to 3SF. I've just given it to 3SF. So hopefully that makes sense. I'm not going to go through the other method. It should be relatively straightforward. You should understand it, but already there's been a long time, so I'm not going to really go through that. But let's see what the answer is. Let me just make sure I am right. So they used that method. They used the masses method, which I'm not really going to go through, but they got 78.6% as well. 78.6% is the answer. That's the percentage yield. So that was my answer there, basically. Hopefully you understand, and that was for the previous worked example. That's the working I did for that. So now we're going to carry on. So we're going to just go straight through this now. So when you carry out chemical reactions, it's not usually possible to collect the amounts calculated from the chemical equations. Reactions may not go to completion. Reactions may be reversible and may not go to completion. Other reactions may happen, and some products may be lost when it's separated or collected from the apparatus. Now, they're the 3 main reasons why we can't have 100% yield. Why we can't have 100% percentage yield. Like, for example, 5.6 grams of calcium oxide can maximum, that's the maximum amount of calcium oxide that can be produced. But in the question we just did, we saw that student made 4.4 grams of calcium oxide. So we can't actually produce 100% yield. We can't get 100% yield. And the reasons for that is, you just need to learn these, that the reactions may be reversible, may not go to completion. Other reactions may happen, or you could say side reactions may take place, or other reactions may happen which could lead to unexpected or unwanted products. You could say that. And also that some products may be lost when separated or collected from the apparatus. Now here's a question exactly like second question of 3 in the section. So why is it not usually possible to get 100% yield from a chemical reaction. We've just been through that. I'll just repeat myself again. Reactions may be reversible, may not go to completion. There may be, there may be other reactions that could take place, side reactions, you could say, maybe, or you could say other reactions. And some products may be lost when separated or collected from the apparatus. Basically, some product, there might be loss of some product when separated or collected from the apparatus. So you just need to learn these, really. Can't really do much about that. This is just something you need to learn, the three things, the three reasons why it isn't practically possible to actually get 100% yield. I don't think you can ever get 100% yield, and it's because of these three main reasons, really. Or these three reasons. Now, what's the answer to this? Yep, so reactions may not go to completions, other reactions may happen, some product may be lost when separated or collected. So, yeah. From the apparatus, obviously. So that's fine. Now we're moving on. So using reactions with high yields in industry helps to conserve resources and reduce waste. Now chemical processes should also waste as little energy as possible. Now that's why it's important to have high yields in industry. Reactions with high yields are good because it helps conserve resources. And it reduces the amount of waste that we produce. Because obviously if we have a greater percentage yield, it means we have much more percentage of what we want, basically. Hopefully that makes sense. But basically, we reduce the amount of waste that we produce if we have a high percentage yield, basically. And the chemical processes should also waste as little energy as possible. Working in these ways obviously helps reduce pollution and makes production more sustainable. So hopefully that makes sense. It reduces pollution. These things that we do, if we we try and maximize the percentage yield, it actually conserves resources. It reduces the waste, and also little energy. The amount of energy wasted, wasted is kind of kept to a minimum, basically. And this helps to obviously reduce the pollution, and obviously also makes production more sustainable. So that's all. There obviously benefits, and you need to learn these things. I can't really do much about them. But why should chemical manufacturers use reactions with high yields? We've just been through that. It's the final question of the section. Well, the answer is just basically to conserve resources, to keep the amount of reduce the amount of waste that we produce, and keep the amount of energy wasted should be kept to a minimum again. Try and reduce these, and this helps to reduce pollution and also to help makes production more sustainable and environmentally friendly and stuff like that. Hopefully that makes sense. And let me just check this answer there. So there we go. So to help conserve resources, to reduce waste and all pollution as well. So yeah, to help conserve resources, to reduce waste and all pollution. You can say all of these things, basically. So we're nearly done with this. So also on the up, you can achieve the top grades if you're able to calculate the percentage yield of a reaction when given the mass of a reactant, use the mass of product obtained and the balance equation for the reaction. Yeah, so we've just basically been through that. Of a mass reactant, use the mass of product obtained, yeah. Cool, yeah, we've just been through percentage yield really, so you need to know that basically. And then the synoptic link is for more information about reversible reactions, see topic C8.6 and to C8.9, which obviously we're going to get to on chapter 8 when we get there. But keywords in the section were yield and percentage yield. And so just the key points to finish off. The yield of a chemical reaction describes how much product is made. The percentage yield, so we know that the yield of a chemical reaction decides how much product is made. We measure the amount of product that we can make using percentage yield, basically. It gives us a good measure of how sustainable the reaction is, how good the reaction is. The percentage yield of a chemical reaction tells you how much product is made compared with the maximum amount that could be produced. The maximum amount could obviously be 100%, but we can't obviously produce 100% in real life because of the reasons. Now the factors affecting the yield of chemical reaction are that the products being left behind in the apparatus or they could be lost, as well. Some of the product may be lost, so obviously also reversible reactions may not go to completion. Some reactants may produce unexpected reactions, which I talked about as well, and also losses in separating the products from the reaction mixture. We've been through all these things, and these things you just need to learn. Can't really do much about it to help you, but that's the end of the section, guys. I really hope this was useful. This section was useful, and make sure to share, like, and subscribe. Turn the notifications on if you haven't already, so you're notified and updated when I upload new videos that you can watch. And also, belated happy birthday to Kim, and I hope you had a great day yesterday, and just a great year ahead and stuff like that. And what else do I have to say? Tomorrow I'm not doing C4.5, which is atom economy. Tomorrow I'm talking about why you should study A-level chemistry, like the benefits about A-level chemistry, and is A-level chemistry for you, and I'll be talking about my experience and stuff like that in that video. And hopefully I'll be able to put the links from to the videos on my website from C3.2 to C4.3, is it? Yeah, C3.2 to C4.4. Sorry, C3.2 to C4.4. And this is only a triple science. This is a triple science students only section, basically. And I think I'll end the video here, guys. Thank you very much. Also, good luck for results day for any GCSE students tomorrow, for all GCSE students tomorrow. And I'll end the video here, and see you tomorrow. Thank you very much, guys.